Welcome to our chemistry cooking show. I'm Sophie.
I'm Christina.
And I'm Gianna. Today we will be going over multiple chemical concepts.
Thermochemistry, why you should mix with a wooden spoon. Heating point, pure substances.
Mixtures, ethylene gas, pigment change, thawing food, oxidation, and caramelization.
We will be creating different dishes and explaining the chemical concepts that go along with it.
Here we have 2 avocados. As you can see, they aren't very ripe because when you try to push down on them, they don't push in, meaning they aren't ripe. But if you stick it in a brown paper bag with an apple, the apple will produce ethylene gas, and if we keep it overnight, then the avocados will be ripe the next day.
Here are the ingredients for the guacamole. Salt, pepper, onion powder, tomato, and 2 avocados.
After we crush up the avocados, we add the pepper. Then we add some salt, some onion powder, and some chopped up tomatoes. Here we have a mixture.
Make guacamole and you don't want it to turn brown. You put a piece of saran wrap over the bowl and then you push it down so it touches the guacamole. You do this because then the guacamole won't react with oxygen that's in the air and it won't turn brown and it'll stay bright green.
Our next dish is going to be penne pasta with broccoli and caramelized onion. The way chemistry is involved in this is the heating point.
To make pasta, we will fill up the pot with enough water to cook our pasta. We will put the gas on medium to medium-high to heat up the water and bring it to a boil. The boil of the water is like Gay-Lussac's law. As the temperature goes up, the pressure goes up. It is recommended to put a lid on the pot, so it, 1, can reduce evaporation, but also the lid traps the steam, causing it to build up pressure. Once the water reaches a boil, we can then put the pasta in.
This is an example of a heating curve. It starts as a solid, and then at 0 degrees it starts melting. Then it transitions into a liquid and starts boiling at 100 degrees, where then will evaporate into a gas.
Now that the water has reached its boiling point, it's time to put the pasta in.
Thermochemistry is the study of the energy and heat associated with chemical reactions and physical transformations. The chemical reaction may release or absorb energy, and a phase change may do the same, such as in melting and boiling. Thermochemistry focuses on energy changes, usually on the system's energy exchanging with its surroundings. Thermochemistry is useful in predicting reactant and product quantities during the course of a given reaction. In combination with entropy determinations, it is also used to predict whether a reaction is spontaneous or non-spontaneous, favorable or unfavorable. In thermochemistry, there is such a thing as endothermic reaction, which their reactions absorb heat. Exothermic reactions release heat. So this works well in cooking because it exchanges energy and heat. A wooden spoon does not heat as fast as a metal one, which is safer so you won't burn yourself.
Our next chemical element is pigment change. We will be cooking broccoli to show this. When cooking most vegetables, you will experiment a color change. When green vegetables, for example, are dropped into boiling water, the tiny air cells in the vegetable connect with the boiling water, and the green will turn into a brighter green towards the stem. When the broccoli is done cooking, you will be able to see the water has a green tint in it. Another example of this is when cooking cabbage, the heat from the water will break down the pigment, changing it into blue. This causes the acids in it to turn to alkane. If you want to regain the color, you just have to add vinegar. We will also place the steamer into the pot. Therefore, the water doesn't come to a boil, it steams the broccoli.
Go. Now the broccoli is a brighter green. Our next concept is thawing frozen food. Melting butter will increase the speed of the molecules in the food. The faster the boil, the more the molecules collide. This ends up changing the molecular structure of the butter, which changes color, temperature, and flavor. Now that the butter's melted, we're going to put the onions in to caramelize them.
Now the onions have caramelized.
Now we'll create a mixture by pouring the pasta, the broccoli, and the onions into the pot and stirring it all around.
A pure substance or chemical substance is a material that has constant composition and is usually homogeneous. It has consistent properties throughout the sample. Water, sugar, salt, and baking soda are pure substances, which are also known as chemical compounds. For example, today in our cooking we use water a lot to boil our food. We also use salt in the pasta.
Most things that we made today, though, are mixtures. If you have some salt in water and then boil off the water, the salt will remain in the pan. The salt is left because it takes very high temperatures to melt salt. And now we are able to eat.